The fascination with life beyond Earth and the enduring legacy of the Voyager mission reflect humanity's age-old curiosity. The question of whether life exists elsewhere in the universe has captivated us for millennia. When we gaze into the night sky, it seems almost inevitable that we are not alone, given the vast number of stars in the universe. Many scientists argue that the odds of life existing somewhere beyond Earth are overwhelming. Renowned science communicators such as Bill Nye have echoed this sentiment, with Nye recently causing a stir among space enthusiasts and scientists alike. His statement regarding Voyager 1's detection of 300 massive objects in space has further sparked intrigue and wonder. The mysterious nature of these objects has led to a renewed sense of excitement about space exploration and the broader implications of what might be awaiting us beyond the solar system. So, what are these objects and where did they come from? Could they offer clues about the possibility of life beyond Earth, or are they remnants of ancient cosmic events that have yet to be fully understood? As we dive into the ongoing discoveries made by the Voyager missions, we unravel mysteries that challenge our understanding of space, our solar system, and the broader universe. For nearly 5 decades, NASA's Voyager missions have provided humanity with some of the earliest and most remarkable views of the wonders of our solar system. These spacecraft were designed to explore the outer planets and have gone far beyond their original missions, venturing into the unknown regions of interstellar space. Surprisingly, the Voyager spacecraft were not built to last this long. When they were launched in the late 1970s, few imagined they would still be operating over 40 years later. The story of Voyager begins with a breakthrough idea in the 1970s. Michael Minovich, a scientist at NASA's Jet Propulsion Laboratory, JPL, had a transformative insight. He realized that a spacecraft could use the gravitational pull of a planet to gain velocity and propel itself further into space, a technique known as gravity assist. This method allowed spacecraft to visit multiple planets without requiring vast amounts of fuel, a breakthrough that paved the way for the Voyager missions. Originally designed to last only 5 years, the Voyager program has surpassed all expectations. Voyager 1 and Voyager 2 were launched just weeks apart in the summer of 1977, with the primary goal of exploring Jupiter and Saturn. Both spacecraft successfully accomplished their missions by providing detailed observations of these gas giants. But their journey did not stop there. After completing their study of Jupiter and Saturn, the resilient spacecraft continued their journey to the outer planets. In 1986, Voyager 2 made the first-ever close-up observations of Uranus, followed by a flyby of Neptune in 1989. These explorations of 4 of the solar system's giant planets earned the mission the name Voyager Grand Tour. With their primary mission accomplished, Voyager 1 and Voyager 2 embarked on an even more ambitious goal: exploring deep space. Now, more than 46 years after their launch, the spacecraft are still traveling, collecting essential scientific data from the far reaches of the cosmos. In 2013, NASA made a groundbreaking announcement. Voyager 1 had officially entered interstellar space. This marked the first time a human-made object had ventured beyond the influence of the sun's particles and magnetic fields into a region between stars known as interstellar space. This region is like moving from a bustling solar system into a quiet, star-filled wilderness. 5 years later, in 2018, Voyager 2 followed suit, entering interstellar space as well. At that time, it was located 17.7 billion kilometers away from the Sun. These 2 spacecraft remain the only human-made objects to have ventured into this uncharted territory. As they journey through space, they continue to provide us with invaluable information about how the interstellar medium interacts with the solar wind emitted by our Sun. One of the most significant contributions of the Voyager missions has been their study of the heliosphere, a protective bubble created by the solar wind that envelopes our solar system. The boundary of this bubble, known as the heliopause, marks the transition from the solar wind to the vast expanse of interstellar space. The Voyagers have sent back valuable data about this celestial shield and its role in protecting the solar system from cosmic rays and other interstellar particles. One of the most remarkable findings made by the Voyager spacecraft is that cosmic rays, mysterious high-energy particles from outside our solar system, are 3 times more intense beyond the heliopause than they are within the heliosphere. This discovery is akin to comparing the tranquility of a peaceful backyard with the bustling activity of a busy street. The Voyager instruments have been able to measure the intensity of these particles, providing scientists with a new understanding of the dangers posed by cosmic radiation. NASA has not stopped with the Voyager discoveries. Instead, the agency has integrated data from other missions to create a more comprehensive picture of our Sun and its complex interactions with the surrounding interstellar space. These efforts have led to a better understanding of the Sun's influence on the space environment far beyond the planets. In 2021, NASA scientists made another surprising revelation. Voyager had detected a persistent hum in interstellar space. This low-frequency sound matched vibrations produced by small amounts of gas floating in the emptiness between stars. The discovery of this hum has raised new questions about the nature of interstellar space and what lies beyond the reach of the Sun's influence. Nicola Fox, the head of NASA's Heliophysics division, highlighted the importance of the Voyager missions in enhancing our understanding of the Sun and its effects on the space environment. According to Fox, the Voyager missions have changed our perception of the Sun in ways that no other space mission could have. But as the Voyager spacecraft continue their journey through the vast emptiness of space, they face increasing challenges. Both Voyagers rely on a power system fueled by plutonium, but as the plutonium decays, it produces less heat, causing the spacecraft to lose power. To conserve energy, NASA has had to make difficult decisions, shutting down non-essential systems and even some initially deemed necessary for the mission. One of the systems turned off was the heater designed to keep instruments warm in the freezing temperatures of space. Despite this, all 5 of the spacecraft's instruments have continued to function, defying expectations. NASA experts remain puzzled as to how the Voyagers are still operating in temperatures that would normally freeze other spacecraft. This mystery only adds to the remarkable legacy of these intrepid explorers. The outer edges of our solar system have surprised astronomers with unexpected behavior. The heliopause, the boundary between the Sun's influence and the space between stars, is not static. Instead, it shifts and fluctuates, creating strange angles that have left scientists amazed and puzzled. This dynamic behavior of the heliopause is not a new discovery. For the past decade, researchers have observed its tendency to change shape using data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer (IBEX) satellite. The spacecraft provide us with direct measurements of the heliopause position, offering valuable insights into the ever-changing boundary of our solar system. In recent years, studies have challenged previous assumptions about the heliopause behavior. In 2014, IBEX detected a strange brightening of energetic particles, suggesting irregularity in the heliopause. These anomalies did not align with existing models, leading to confusion among researchers. Moreover, scientists observed significant changes in the heliopause position over short periods, which might explain why Voyager 1 and Voyager 2 reached interstellar space at different times, in 2012 and 2018 respectively. The unexpected behaviors of the heliopause have sparked debates within the scientific community, but researchers are eager to learn more. NASA's upcoming Interstellar Mapping and Acceleration Probe (IMAP), scheduled for launch in 2025, is expected to provide new insights into the outer reaches of our solar system. Until then, scientists continue to wonder about the mysteries that await beyond the heliopause. The Voyager missions have encountered their share of technical challenges along the way. In May 2023, Voyager 1 experienced an unusual event during its routine operation. The spacecraft's Attitude Articulation and Control System (ACS), responsible for controlling its high-gain antenna, began sending back confusing data. Instead of the usual updates about the spacecraft's health and status, the data appeared incoherent, as though the spacecraft was struggling to communicate effectively. Despite this issue, Voyager 1 continued to function normally, with its radio signal remaining strong and stable. NASA quickly identified the problem. The ACS had switched to using a computer that had been inactive for years. The solution was simple. NASA sent a command to switch back to the working computer, and the spacecraft resumed normal operations. Although this incident did not pose a significant risk to Voyager 1, it serves as a reminder of the challenges faced by spacecraft operating in the harsh environment of interstellar space. Both Voyager 1 and Voyager 2 are exposed to high levels of cosmic radiation, which can interfere with their onboard systems. Over time, energetic particles can cause small memory errors in the spacecraft computers, but NASA has successfully managed these issues. Susan Dodd, the project manager overseeing the Voyager missions, notes that encountering such mysteries is now a normal part of the Voyager journey. These spacecraft have been traveling for nearly 5 decades, far longer than their expected mission duration. As they venture through interstellar space, they face unique challenges, navigating through an environment filled with high levels of radiation unlike anything previously explored by a spacecraft. Nearly 50 years have passed since Voyager 1 and Voyager 2 set off on their remarkable journey. They have traveled across vast distances, exploring unknown realms and uncovering groundbreaking knowledge about the solar system and beyond. Despite their technological limitations, Each spacecraft operates with just 70 kilobytes of memory. NASA has managed to keep them operational, sending software updates across immense cosmic distances to ensure their ongoing function. The exploration of the outer planets, specifically Jupiter and Saturn, was initially an ambitious yet finite goal. However, the Voyager mission's unexpected longevity has turned them into much more than interplanetary explorers. They have become ambassadors of humanity, carrying with them the famous Golden Record, an artifact containing sounds and images of life on Earth, designed to convey the story of our civilization to any potential extraterrestrial beings who may encounter the spacecraft. As of today, the Voyager spacecraft continue to push the boundaries of space exploration, venturing further than any other human-made objects. Their legacy is a testament to the ingenuity and perseverance of the scientists and engineers who designed them. Even as the spacecraft age and their power supply dwindles, they remain vital tools for understanding the mysteries of the universe. The Voyager mission exemplifies the spirit of discovery and the desire to explore the unknown,